Good morning, class, and welcome to our second video in our unit on graphs and data. Last time we talked about translations. Today we're going to talk about reflections. If you remember from last video, a translation or a slide means we're taking a figure and moving it from one place to another without turning it or reflecting it. Now that was important to note because I said some types of transformations will turn or flip your shape, and reflection is one of those. So we'll take a look at what that looks like, but before we do, if you haven't already done so, go ahead and write down your topic, essential question, make your columns, and fill in these vocab words that we'll be talking about. The first one we have is line of reflection. Now whenever you're told to do a reflection, you'll be told to reflect it over a specific line. That line is usually the X or the Y axis. So when it tells you to flip over an axis, you want to think about that axis as like a mirror, and it's the line that we're going to flip over. So it's going to move to the other side of that line and be the same distance from that line. Just like with mirrors, when you're further away from a mirror, your image looks further away. When you're closer to the mirror, it looks like your image is closer to the mirror. Okay, the reflection, also called the image, is the new figure after it's been flipped. Remember, an image is just an overall word for what happens to a figure after it gets transformed. Transformation is also a general word for any type of change to the original figure. So a translation was a type of transformation. Reflection is another type of transformation. Moving on to our first example, let's take a look at this triangle. So this says to reflect the triangle ABC over the y-axis and list the coordinates of the new vertices. So let's do the reflection first, and we'll take a look at the vertices. So this one says reflect over the y-axis. Remember, the y-axis is this vertical line right here. Okay, so if I'm going to reflect over that line, I'm thinking about this as my mirror. So point A, if I want to reflect it, I'm going to go straight towards that mirror and onto the other side. And I want to go onto the other side the same distance as I am from the mirror on this side. So A is 1 point to the right of my mirror. I'm going to move it to 1 point to the left of my mirror. Okay, and just like with before, I'm going to call that point A prime. Okay. B is also 1 point to the right of the mirror, so go straight towards the mirror and past it 1 point to the left. Now that is going to be point B prime. Okay. C is 1, 2, 3 points to the right of my mirror. So if I go straight to the other side, I'm going to go 1, 2, 3 points to the other side. So that's going to become C prime. From there, I can connect the dots, and it should give me a triangle that looks very much like the triangle I had before I reflected, except we flipped over. Okay, something like that. Now, thinking about the vertices, if I look at my original triangle, this point here was 1, 2. Because you got to go over 1, then up 2. If I look at what happens to the reflection of that point, instead of going to the right, I go left 1, because of what my reflection does. So instead of 1, 2, I got negative 1, 2. It's still at the same height, but it's to the left instead of the right. Okay, for B, my original coordinate was 1, 5. So I'll write 1, 5, and it's the same change for my reflection. Instead of going to the right 1, I went to the left 1 before I went up 5. So that would be negative 1, 5. For C, the coordinates of that first point are 3, 2. And when I reflected it, instead of going to the right 3, I went to the left 3, which means this is point negative 3, 2. So the thing that's changing in each case is just that the x-coordinate is changing sign. So instead of a positive, I had a negative. If my original coordinate was negative, I would have ended up with a positive, because it just changes. Okay, so let's see if that same thing happens on our next example. Here it says to reflect rhombus WXYZ over the x-axis. So here's my x-axis. This is going to be my mirror now. So instead of flipping side to side, it's going to flip up and down. Okay, so let's graph our points. First point is at 2, 0. Okay, that's W. Second point is at 1, 3. That's X. Okay. Third point is at 4, 3. Right here, that's Y. And last point is at 5, 0, which is Z. Okay, so if I reflect those points, W is already on my mirror. So if you think about in a mirror, if you get close enough with your finger that it touches the mirror, it looks like the image, the reflection of your fingertip is at the same point as your finger, like they touch there. So if it's already on the line, it's not going to go anywhere. It's just going to stay on the line. Okay, so that'll happen with both W and Z. For X, X is 3 above the line, so it's going to flip down 3 below the line. So that's X prime. For Z, or for Y, that is also 3 above, so that's going to flip 3 below. And that's going to become Y prime. Okay, if I connect the dots, I'll connect the dots to the original figure first. W, X, to W. Okay, and then for our reflection, we got that line, and that line. You can see it's the same shape, only flipped upside down. Okay, now looking at the coordinates of my original A were 2, 0. Well, it stayed 2, 0. Same for Z. That point didn't change. So we got 2. For X, X was at 1, 3, and it became 1, negative 3 because I went down instead of over. So I got 1, negative 3. For Y, it was 4, 3. That became 4, negative 3. So in this case, instead of the X changing, the X stayed the same. It's the Y that changed. These 3's became negative 3's. 0 stayed 0 because there is no negative 0. Okay. But when I flipped over the Y-axis, because I was going down now instead of up, the Y coordinates changed signs. Okay, I'm going to pause the video here to let you try one on your own. Here we're given the coordinates of a triangle. Please mark those coordinates, reflect it in your notes. So draw on the graph, do the reflection in your notes, and then write down the coordinates of the reflection. We'll check in to see how you did after you try it. Okay, hopefully you got a picture that looks like this. Well, here's our original figure, here's the reflection, with these as your new coordinates. Summarizing that, anytime we're reflecting over the x-axis, what happens is the y-coordinate changes signs. Whenever we flip over the y-axis, the x-coordinate changes signs, as we saw. Last thing we're going to do here is to just use that information, try to answer a couple questions without having to bother with the drawing. So in this first one, we got a triangle that's being reflected over the x-axis. Remember what that means is that the y-coordinate is going to be changing signs. So if we're told that L is at 2, 1, I want to know where L prime is. I just have to change the signs on my y-coordinate. The 1 becomes a negative 1, and I'm looking at answer D, 2, negative 1. Okay. For question 2, here we have a triangle again. It's being reflected over the y-axis, which means the x-coordinate is one that's going to change. If this is Q and I want to find Q prime, I just take my negative 3, change it to a positive 3, and I have 3, 2 is a coordinate of the reflection of that point. I'll pause here again to let's try a couple before we conclude our video. Alright, hopefully those went well for you. If not, remember to contact me between the hours of 10 and 12 or 1 and 3, and I'd be happy to answer any questions you have. Otherwise, I will see you in the next video.